Hello and welcome to our lesson on development of the periodic table. This lesson we're looking at the periodic table. What is it? How did it get to look like this? And why is it arranged like this? If I asked you to put these elements in order, what would you do? Well, you've probably put them in this order, with lithium with number 7 being first, carbon with number 12 being second, and potassium number 39 being third. It's logical. You may have done it the other way around, but I doubt it. It's a logical order of things, a way of arranging things that maybe don't make sense to us. Where do we start? We put them in some sort of an order, a pattern. What can we see? That's exactly what the periodic table is. It's simply taking elements that maybe we understood or we didn't understand much of at the time and putting them into some sort of order to try and understand what's going on. But who invented or who created the periodic table? Well, John Dalton's the first person to get credit for any kind of work here. Now, we've met John Dalton before when we looked at the theory of the atomic model, so you should recognise his name. If it rings a bell, that's why. But he knew about a number of elements, and he was able to calculate the atomic mass of all those known elements. And then he put them in order, the lightest first, and then the second, all the way to the heaviest. And you can see here some of those names look quite familiar. We've got carbon, we've got oxygen, we've got gold, and then we've got some maybe that don't seem to sound familiar, like lime. Now that's probably going to be calcium because you find calcium in limestone. So potassium. So you can see where he's going with this one. John Dalton's work stood for quite some time. And it wasn't until John Newlands came along that any further work was really done on the periodic table. Now, John Newlands built on John Dalton's ideas, and that's the way it goes in science sometimes. That's why it's really important to share those ideas so other people can take it on to the next step. And John Newlands did exactly that. So again, he put the elements in order of mass. Now, actually, you can see here he's actually got a few more now. We're 1866, so we know a little bit more about the world around us. We've found some elements we didn't know existed, and so he's put them in again in order of mass, and now he's got a few more. What he's starting to see a pattern, and John Newlands was the first person to discover that it appeared that every 8th element was similar, and so he put them into octaves, so oct meaning 8. He put them into groups of 8, so every 8th element had something in common, and he called this the octaves rule. Now, unfortunately for John Newlands, it wasn't perfect. Some of the elements fit, but some of the elements didn't really seem to fit that pattern perfectly. It was a Russian scientist named Dmitry Mendeleev who took the next step and to develop John Newlands' ideas. Now, again, he put the elements in order of mass, but what Dmitry Mendeleev did to address John Newlands' problems of the patterns not quite fitting is he left gaps. And what he said was, I predict that there are elements we don't yet know about that fit in these gaps that then make sense of the periodic table. And he was spot on. A tremendous leap of faith really for a scientist, but it worked much better leaving these gaps and actually something like, I believe he actually called it gallium. Gallium was one that he was discovered later, and Dmitry Mendeleev had actually told us, I predict it's going to be grey, it's going to be shiny, it's going to be a metal. He predicted its melting points, its boiling points, because he understood the patterns of the elements around it, and he was spot on. So we tend to think of Mendeleev as the inventor of the modern periodic table. So today, our modern periodic table that you can see here on the right obviously looks very different to the one that Dmitry Mendeleev came up with in the 1800s. That's for several reasons. Obviously, we have much more knowledge of the world. We have discovered many more elements since Mendeleev. We've filled in a lot of those gaps he's left. But also was the work done on the atom. So remember what we talked about from Unit 1. We discovered the proton, we discovered the neutron, we discovered the electron. So that changed massively how we understood the elements and why they form the patterns that they do. The one thing the exam board want you to recognise, and you may be asked about, is the difference between the modern periodic table and Dmitry Mendelev's periodic table. And the big one is in the blue box. Our modern day periodic table is arranged by atomic number. So that's the number of protons, not by atomic mass. And it's just slightly more accurate than Mendelev's version. Okay, so let's look at how that might be approached in the exam. I've got an exam question here. It was a 6-marker, so you might pause the video in a few minutes and maybe just jot down some ideas. Where do you think you're going to get those 6 marks from? Before we go any further though, let's just book the question. It's always worth it. If you're not sure what you're doing or you're a little bit panicked, it's like, how am I going to approach this? Book the question and it will give you an idea of where you need to start. So first of all, it says look. That is a command word, look at the table. Okay. Now normally the table would be there, data table would be there to be used. It might be in this sort of question though, it's just being given for context. So you just need to bear that in mind. It says look at the table. It shows part of an early version of the periodic table of the elements. The numbers are the relative atomic masses of the elements. Okay. 3 chemists helped with the development of the periodic table. One was Dobereiner, who noticed triads such as lithium, sodium and potassium. The other 2 chemists were Newlands and Mendeleev. Write, what am I writing about? About the evidence that Newlands and Mendeleev used to develop the periodic table. So straight away you're probably thinking, Mrs. Newsom, you have not taught me about Dobereiner and triads. But the point is, I haven't needed to tell you about Dobereiner and the triads. The question is all about Newlands and Mendeleev. Dobereiner does not appear on the curriculum. So, what do you know about Newlands and Mendeleev? I suggest you pause the video, have a think, and then start the video when you're ready. Okay, so here is the mark scheme from the exam. It's worth noting in the red box there that even for 6 marks, all they were really looking for is one piece of evidence that they both used, like the atomic mass. One thing that Newlands did on his own, so the examples it gives are the every eighth element is similar, the fact that the pattern didn't work perfectly, and then something that Mendeleev did on his own. So he left gaps. He realised not everything had been predicted or discovered yet. It's also worth noting that there's some answers there that maybe I've not mentioned, and this is one of the reasons why looking over exam questions is so very helpful. It gives you more of that kind of what is OCR actually accepting. So hopefully you found that helpful. That's the end of this lesson, guys, and I will see you next time. Bye.